Hey pre-calc class. So last time we started talking about polynomial functions, and we reviewed some things that we learned previously. These are our notes. If you haven't watched the previous video, please do that. I put a note form in there that you can use. So take some time to do that and fill this out so you have this as a reference moving forward. We'll reference this quite a bit in the next couple weeks. Okay, today we're going to start talking about end behavior a little bit more, and then also turning points and finding increasing intervals, decreasing intervals of polynomials, things like that. Before we do that, I want to talk about something called interval notation. So you guys are familiar already with how to write inequalities. So something like on the upper left there, x is greater than 5. Okay, well, there's something called interval notation, which also is another way to write this. So the way we do this is parentheses mean that the number is not included, okay? If you want to include it, so like if we want to include 5 here, we would put a greater than or equal to. But if we want 5 not included, then we would do that. Okay, so now if we do interval notation, we use a parenthesis if we don't want to include 5, okay? And we would use a bracket. So we would use this if we wanted to include 5. For our purposes, we are almost always going to be using a parenthesis for this. So that's kind of why I'm just sticking this to keep it simple. Okay, so 5, and then you go say, you put a comma, and you say how 5 goes up to what? We kind of go from left to right. So if x is greater than 5, you know everything bigger than 5, and that goes all the way up to infinity. Just keeps going, right? So my interval would be from 5 all the way up to infinity, and you would close that out. So it's called interval notation. These two things mean the same thing. It's just written a little differently, right? So for that middle one, it says x, -2 is less than x, which is less than 3. That's a fancy way of saying x is everything between -2 and 3. So how do we write that? Well, in interval notation, we would start at -2, and it goes all the way up to 3, and we close it there. Now, -2 and 3 are not included, so we use parentheses still, okay? And then this one, I'm just going to go ahead and put the parentheses right now. This one actually is a little confusing. It says x is less than -7. So remember when we do interval notation, you always have to start from the left. From the smallest number all the way up to the biggest number is going to be the one you write on the right. Okay, so the smallest number here, it's going to go all the way up to -7, which I guess would be the biggest number. But the smallest number would be -infinity, right? So -infinity up to -7. So that's kind of weird. So just kind of think about that. When we write interval notation here, we start from the smallest number first, then the biggest number. So that's how we got that. I hope that makes sense. Kind of a crash course on interval notation, but it'll be easier to understand when we're getting into the stuff today. Okay, so today we're going to start to talk about turning points. A turning point is just a point at which the polynomial switches directions. Okay, so in this particular case, I have 2 turning points, one here and one here. And why are they called turning points? Let's talk about that a little bit further. Okay, so this, when we read a graph, we read it from left to right, just as we read a book, okay? So now in this graph, as we start from left to right, this right here is it's increasing. So this is called an increasing interval. It gets to that top, that turning point, and then it's just stable for a second. And then it starts to decrease, okay? Gets to that other turning point, and now it's starting to switch and start to increase again. So this one really has a few direction changes, okay? So that's an important thing to keep in mind. All right. Now, if the turning point is higher than any nearby point, it's called a relative maximum, okay? So this point right here, this is called a relative maximum. Okay, Why a relative maximum? Well, this point right here is not the highest point on the graph, right? This keeps going all the way up to infinity. So technically, the maximum would be infinity, right? But that blue point there is the relative maximum, because when we look in terms of relative to the points that are near it, it is the highest point, okay? So that's why we call it a relative maximum. And so as you might guess, this lower one here, that's called a relative minimum. Okay, if the turning point is lower than any nearby point, that's called a relative minimum. Okay, now you can have multiple relative minimums. You might have two minimums and one maximum, something like that. You'll see that in a couple of problems that were called. But maximum and minimums are called extrema, like extremes. Okay, so extrema. I had a professor, he always called it extrema, but that's not how you pronounce it. So it's extrema, I guess. So turning points define where the function is increasing or decreasing. I kind of talked about that already. Okay, so how does this work? Well, in this section here, find the turning points of the function, and I have the function x cubed minus 6x squared plus 7x plus 2. I don't want to go through this whole thing, but what we're going to do is, these are the steps, and I'm going to show you how to do that. But if you want to come back and look, sometimes you have this video, but these are also the steps. Now, when you graph this, you'll get this picture here on the left. And I wrote out the relative maximum there is 0.71 comma 4.30. And the minimum is 3.29 comma negative 4.30. So we're going to learn how to find those. I really am not too worried about that right now. I do want to talk about these, you'll notice here, increasing and decreasing intervals. So let's talk about that, okay? Now, using this picture, an increasing interval is where it's increasing, right? So in this, let me switch to a different color here maybe. In this graph is increasing. Remember, we read it from left to right. It's increasing from this interval here, okay? So if this point right here is 0.71 comma 4.30, we're thinking from this to here, right? Left to right. You're going to write the x values, okay? So from negative infinity all the way up until this point right here. Where does this stop? Where it stopped increasing? It's 0.71. So notice I wrote increasing interval, negative infinity to 0.71, okay? Just the x values from there to there. Then it's also increasing from here to here, right? But we're going this way. So what's the x value? Well, notice 3.29, and then that just keeps going all the way to positive infinity. So that's how I got this, okay? All right, so those are my increasing intervals. Now my decreasing interval, let's do orange. The decreasing interval is right here, right? So this point, right, we already said is 0.71 comma 4.30. So the x is 0.71, and that goes from here to here is going to go to 3.29. So that's how I got this part right here. This is kind of weird. It's going to take you some getting used to. So it's okay. We're going to practice this a number of times. All right? Okay. We're going to go through a couple of these problems. I don't actually want to go through the first one that's listed on your page. I think it's actually maybe a little more confusing if we go through that one. So I want to start by getting to the second one. So if you would move to that and just kind of follow along and make sure this makes sense. But we will need our calculators to do this. You will need your graphing calculator. So I'm going to open that up. Now, I don't know if you guys have had any problems with this, but if you open up your MCA calculator, when I type grades 8 and 11, the last couple of days, I've been getting this blank screen, and it's not working. So the workaround around that, if that happens to you, maybe it's okay for you. But for me, one of the things you can do is in the upper right, you'll see a little compass. It's like a circle with a diamond in the middle. Just tap that, and it will go to Safari. Okay, and then it seems to work just fine. It starts up, just press start a couple of times. I don't know why that is, but if that's happening to you, that's a workaround. Hopefully they fix that pretty soon. Okay, now the first thing you're going to do is you're going to type in the function. The function was x to the fourth plus x to the third minus 4x squared plus 5. So you're going to press y equals, and we're going to go x. In order to raise it to the fourth power, you're going to see this caret button right above the divided by sign. Okay, and that should raise it up, and then you're going to type in 4. Okay, now in order to continue to type, you're going to have to hit the right arrow key, so to drop down so you're not still in that exponent. So it goes back down, okay? And now I'm going to go plus x to the third. Again, I'm going to have to hit the right arrow key to drop it down. Minus 4x. You have the squared button, so I like to use that instead when you are getting squares. And then plus 5. Okay, after you do that, just hit graph. Now you'll notice you get this picture right here. I'm not ready to quite graph that yet and put that onto my paper yet. What I really want to focus on is finding my relative minimums and maximums. So that's actually what I'm going to start with. So I'm going to do that first. I want to find that first relative minimum on the left there. You can see the lowest point on this graph. So how do we do that? Here's how. You're going to use the calc function, which is right above trace. So you'll see right above the trace button, it says calc. So we're going to go second calc. Okay. Now we're going to go down to minimum because it's a relative minimum, and I'm going to press enter. Okay. Now on the bottom of the screen, you'll notice it says left bound. What you are going to do is you are going to move your cursor to the left of that minimum value. Okay, so I'm going to say somewhere like that. Okay, now I'm going to press enter. Then I'm going to go and I'm going to move it to the right of that minimum value. Okay, so it says right bound. We're going to press enter. And then it says guess. Now you'll notice the calculator puts a couple of lines. You're telling the calculator, I want you to look at these values just between those lines and tell me what the minimum value is. So you're going to press enter one more time. We don't want guess. You want to get to the spot where it says minimum or maximum. Okay? You will always round to 2 decimal places. Make sure you're rounding properly. Notice here it says negative 1.838. We're going to round that to negative 1.84. Okay? And then the y value is negative 3.309. That will be rounded to negative 3.31. Okay, so that is our first relative minimum, and I'm going to write that down. Okay, I don't want to do a split screen because it might drop on me. Okay, so my first relative minimum, notice this is my relative minimum, so I'm going to write that here. I'll change colors here. Okay, relative minimum, negative 1.84, comma, it was negative 3.31. Now we have another one, so I'm going to do that. Now notice I'm doing this before I graph it, and I'll explain why here in a second. Let me double check that that was correct. Yeah, negative 1.84 and negative 3.31. Okay, cool. Once you have that, now we still have the graph there, so you're just going to press second calc again, and we're going to do another minimum. So enter. Okay, so the other minimum is this point right here, right? So I want the left bound, so I want it to be left of that point. That looks pretty good. I'll press enter. Then I'm going to go to the right of that, press enter. Now notice in between the lines should be my point that I'm looking for, okay? Press enter again, so it says minimum. Now I have 1.0880885 and 2.95 for blah, blah, blah. Okay, round to the nearest hundredth, 2 decimal places. So that's 1.09 and 2.95. Okay, so that point. So now this is not interval notation. You're just writing the point, right, as an ordered pair. So this is 1.09, comma, 2.95. Okay. Now we're going to do the relative maximum. Okay, so I'm going to go second calc again. This time we're going to go to maximum, press enter. Okay, so the maximum is this point right here. I always want to start with the left bound, so I'm going to do left of that, press enter, and right of that, press enter. Okay, now I'm going to press enter one more time. It says maximum. Okay, now I want to focus on what this says here. It says 4.7817 e to the negative 7. This just means, this is like time, this is scientific notation. It's when you see that e, negative 7 means move that decimal 7 places to the left. So this would be 0.000004781. So really, if I round that to the nearest hundredth, that's going to be 0 still. Okay, so I'm going to say this is the 0.05. That's a little weird. You will see this occasionally. One of the reasons I wanted to go over this one, but 0 and then the y value was 5. Okay. All right. Now those 3 points I'm going to plot on my graph first, and then I'm going to connect and see what else I've got. Okay. So 0, 5. That's pretty easy to do. That's right there. Negative 1.84. So, and negative 3.31. Okay, negative 1.84, negative 3. Somewhere in that neighborhood. Try to be pretty accurate as you can on these iPads. And then 1.09 and 2.95. Okay. All right, now those 3 points, once you have those, now what does this look like, right? It looks like this. It's kind of like a W sort of shape. Okay, so I'm going to connect these as best I can. But those points, those 3 points that you have, should be represented. Your minimums and maximum should be represented. Okay, now let's talk about the rest of this. Okay, and then we're done. Domain. The domain, remember, set of possible x values. So you'll notice, if I think about what are my possible x values, this graph keeps going this way, right? This goes up. This graph keeps going up. But it also gets wider. So that means it keeps going to the left. This also goes up, but it keeps getting wider as well. So it keeps going to the right. Well, it's going all the way to the left and all the way to the right. So that really means every single number. Okay, the abbreviation for that is all real numbers. We can abbreviate it like that. So the domain here is everything, which is all real numbers. The range, sometimes you'll have the range is also all real numbers. In this case, it's not. Okay? The range, right, is your y values, possible y values. And this one goes all the way up to infinity, but it doesn't go all the way down. It stops right here. This is the lowest it gets. Now, remember, we already wrote what that is. That point is negative 1.84, comma, negative 3.31. So what's the lowest this gets? It's negative 3.31. That's the y value there, right? So really, when I'm thinking about what is my range, it's everything bigger than negative 3.31. So I'm going to say y because it's the y values. It has to be greater than or equal to negative 3.31. Now, if you want to use interval notation there, you can. I just like for those to just keep it simple and do that. But with the other ones, it's easier to use interval notation, I think. Okay, end behavior. As x goes to infinity, as x goes this way, what happens to y? It goes up to infinity. Okay, as x goes to negative infinity, what happens to y here? This also goes to infinity. Okay, and then now let's write our increasing and decreasing intervals. So let's see. It is increasing from here to here, okay, in that segment there. So that is from negative 1.84 to 0. Notice those are my x values. And then it's also increasing from here to here. So that would be, let's see, 1.09, comma, infinity. I'm going to move this over. Okay, those are my two increasing intervals. Now let's do our decreasing intervals. So we have a couple of these as well. Okay, so we're decreasing from here to here. This would be negative infinity to negative 1.84. And let's see, decreasing in this section here. That would be from 0 to 1.09. Okay. And there we go. We've done it. All right, lots of new information. You have, let's see, 4 or 5 of these on your assignment today. There's 4 of them, along with some other stuff that we learned last time. Good luck. I hope this makes sense. If not, come and see me during Ask the Teacher time.